And here we are. This is what the interactive GUI looks like for local normalization. It's actually pretty cool. Now, one of the things that I don't yet know is if this is just a me problem or everyone problem. This is the image. Now, this shouldn't be a blank screen. It should probably show up with the image at some reasonable zoom level. But if you look at the zoom level down here, it's like some crazy number. So I just roll my cursor here and I zoom in until I get to, down to reasonable zoom, and then you can see the image. And the whole idea behind the interactive mode is that we can choose to either have a reference frame from a single best image, or we can do integrate a set of images. So let's just consider a single frame. Now, why would we want to choose a single frame? Well, if we let it do it automatically, it's going to pick one. It would pick this one without our intervention, which is usually probably going to be okay, whether it picks one or it picks a set of frames. But as you'll see, I think I can demonstrate in this data set, it won't always be the best. And it might be nice to look and see which frame it's picking, because if there's something wrong with the frame, then you might want to select another one. That's the basic idea here. So, looking at this frame, I don't see a problem with that. And then we can click on other frames and we can look at those frames as well. So these frames look okay, but the one it picked is fine. So let's talk now on how we're picking. The evaluation criteria is the way in which Pixinsight, specifically WBPP, it's looking at the numbers that were measured. And this method, you should watch my videos about the weighting schemes in Pixinsight. Please check those out. I explain in all possible detail what all of these parameters mean in my videos on my site. So if you haven't seen that information, even available publicly, there is a presentation all about weighting, but I have much more detail, of course, on my videos that are on my site. So, but the PSF signal weight evaluation criteria is a particularly good one for finding best frames, because it takes into account both perhaps star characteristics as well as the fundamental characteristic of the amount of signal that's there. So let's look at the columns that you can't see. So these are the same, these columns here are the same as what you'll see in the pull down menu. And if I switch a method, you can see that it's now going to arrange the images according to the criteria from best to worst based on this particular method. In this case, it's PSF SNR, which, by the way, I wouldn't recommend. In general, that's the noise estimate one. That's the one that can be fooled by differences in background brightness. If you don't have those differences in your data, it's probably okay. But in a moment, I can demonstrate that it does actually give, it chooses different images here, and that may or may not be appropriate. So these are the best ones of the set that it's calculating, or the best one. If we wanted to do a set of them, we can choose to do the integration of the best frames. And I'm going to go back to the PSF signal weight. So I have selected here 4 frames. You can choose, I think that's the default, but you can choose as few or as many as you would like. And here, these 4 frames, we can look at them, because what we will do in a moment is integrate them together to make a reference. So let's look at the frames. Do they each look okay? And the answer is yeah, they look fine. These 4 frames actually do look just fine. So there would be no problem in my mind with it going ahead and integrating. Now, what if it had been this frame down here? That is not a good frame. I looked ahead at this particular set of data. That's not a good frame. Probably a cloud got in the way there. So we don't want it to pick that as a reference of any kind. And furthermore, when we get to the point, now this is outside of local normalization, but when this frame is actually measured, I suspect, well, it has a measurement even now, but I suspect the measurement is the weight given to this frame is so low, this might be one of the frames that is not going to meet that criterion of being better than a weight of 0.5. So you remember I set that up in WBPP. It's for exactly this purpose. This kind of frame doesn't do us any good. There's no sense in adding that frame. The other frames look okay. Just checking them out here. But yeah, they look okay. All right. So what else? I wouldn't mess around with these other things. And let me just specify this. Let me just say this again. In general, if I thought that the data was very clean and there wasn't any issue with it, I probably wouldn't use the interactive mode. It's where I have a specific reason to look at the data, either because I need to assign, I need to be sure that it's using a particular set of frames, or I think that the frames are so variable, the data set that I'm working with is so variable, I really want to look and make sure that I'm getting the best possible reference for local normalization purposes. This does affect both the look of the image, because it does deal with the fact that in normalization we're matching kind of gradients, but also it affects the rejection of images, because how good that matching is affects how well you can reject things just like this, just like these satellite trails. There being a satellite trail here is probably not a problem when we're doing the integration of many frames here. Let me now show you what that looks like. Let's say instead of doing a single best reference, single best frame, we're going to take from a set of them. So we have a set here, and again, we're using the PSF signal weight. We can use any of these things, but I think my recommendation is just use this, PSF SW. And what you need to do, if you're going to use a set of them, because we're deciding that's exactly what we want to do here, you have to generate it. So right now, if I just went select, it's not going to automatically do the integration of 4 frames. We have to do that now. Once we've chosen the frames, you press the generate button, and what it's going to do is invoke image integration behind the scenes. You can maybe see things going on in my console over here. And it'll generate that integrated image. Just give it a moment. And it'll pop up right here. And then that will be the frame, of course, that we wanted to use. So here we are. We can now see the integrated frame. And you can see it has a special little circle there by it. That's the one it's going to choose. So we're all set to go ahead and hit the select button, which is the one that we will actually continue from this point. So let me go ahead and do that. And when it'll now continue to do the execution of the script, and we will get to the next color. Again, just as a reminder, it's going to stop at each of these. So we'll stop on apparently the green set next, and then we'll look at those frames. But that's how it works with this interactive method. So here we are with the green set of data. And we're choosing, again, from among the set of images, some of the best images here, as measured by PSF signal weight, to combine to create an integrated result. But look at this. I'll put it back on 4. I got to 5 here. But this first frame, even though it measures very high, probably because there's a doubling here of the stars, that's actually not a good frame. We would not want this to be either part of a single reference or really even integrated into the set of images that might make a reference frame for local normalization. We should exclude this one. So that's exactly what the exclude button is for. Again, let me just stress that if we did this in an automated way, it would have chosen this. If we had this as a single best frame, it would have chosen this particular frame. The fact that we do in the integration of best frames would have mitigated the fact that we had one kind of goofy one here. The others are probably just fine. So let's see, the other frames in green here are good frames. You can see some of the RBI, residual bulk. You can see the leftover image of the bright stars that got off, but everything else looks okay here. This frame, not so good. So well, first of all, I'm going to go back to 4, and then I'm going to exclude the goofy frame. And what happens is it just chooses the next, the next best one in the list. So now we have the 4 top frames, and this frame, is it good? And it is. It's fine. So these frames will make a fine reference. And what we can then do is, of course, we'll generate that integrated result. So here we have the integrated result. Now, I want to say something about the satellite trail. I think in general, you probably should choose frames that don't have bright satellite trails. It's okay if they have a dim one, but not a bright one. I don't have a choice in this particular case. This field is in Orion. All of these satellite trails are due to the geosynchronous satellites. Almost every frame has some satellite trails in it. So I'm not going crazy about trying to find the best frame in that sense. I'm just letting it be. So this is going to end up being the reference, and there may be some, you know, something to the fact that there's a bit of a satellite trail in there, but I'm just not going to worry myself too much about it. So I'm going to press the select button and continue. There we go. And if the red has anything remarkable about it that I should point out, I'll stop the video again. But otherwise, I'll just take care of the red, and the luminance might be a really good one to look at because there are many more frames there. So here I am now looking at the luminance data, and what's interesting is that you can see the algorithm is actually picking the number of frames to integrate together. It's based on the total number of frames that you have. I don't know what it is. How many frames do I have here? So we have 36, and it shows 12. So obviously it's 3. So 1/3 of the frames, I guess, is what is being integrated together, but we can change the number to whatever it is that we might want. I would think 7 frames should be sufficient, but that's me. 12 frames is perfectly fine. It's just I run into, you know, the greater likelihood that some of the other frames might have some goofiness going on in there with satellite trails or anything else. Maybe one thing that might be nice here, especially since this is luminance data, I can go ahead and maybe try to only include frames that have fewer satellites. Because they otherwise look okay. So that one's okay. This one, I'm not going to worry about those little things. That's okay, that's okay. See, that one is a big one. Let's exclude that. That's okay. Okay, I'll accept it. All right, so there we go. I have now excluded some of the frames that have larger satellite trails just to demonstrate that we can do that kind of thing. And I'm going to leave all the other settings the same. So we generate, and then I'll hit the select button to tell it to go. So here then we have generated that, and I can hit the select button. Here we go. So now everything else is automated. There's nothing else I need to do. In fact, with that being the luminance, all it really needs to do at this point is integrate, and then we'll be done with the WBPP execution, done with the pipeline. All right, so here's the result. At least it's finished. One thing that I do note is that we do have a little purple circle here. It indicates one of the frames had a problem doing the local normalization. It's not surprising. I didn't look at all the frames, and there very well could be a very poor frame with clouds. So hopefully the weighting bit is going to take care of that anyway, and I'm just not going to worry about that. So here is a little more summary detail of what unfolded here. It does tell me which file is the problematic one as far as the local normalization is concerned. But everything looks pretty good, so I'm going to go ahead and press done. You can see that now in WBPP the masters that have been generated are populated. If I were to run this again, of course it won't go through and recreate them. It'll just use the masters that are already there. And these masters are saved in the folders, and so that's the other thing we should look at. If we exit out of here and we look in the results area, I think this is not the correct directory. I think I was doing number 2 instead of number 1. Here are the results. We should find in the masters folder, we're going to find a number of things, and I just want to be sure there's no confusion about this. We're going to find these integrated things. These are the frames that were used as a local reference, a local normalization reference. So these are, of course, not the results. These are an intermediate frame, although we can look at them if we wanted to and check out, you know, how they looked. We saw them effectively earlier. It's interesting that since the, let's see, we did blue, green, red. Since the blue and the green both used 4 frames, that it the file name is the same, so it is a different file. They just added the extension there. That might need to be handled more eloquently, so I'll mention that to Roberto, the developer. But everything looks correct. You can even see it integrated 7. You recall on the Luminance did more frames. And then we can look at the light result, the actual master light frames in each of the colors. So let's look at, I don't know, I can open them all, I guess. There they go. Now remember, each one of these frames comes with its own rejection and all of that. So here, these are rejected stuff, which looks good. This is the red, and I can see that there's rejection. Now that doesn't mean it's going to be perfect. Oh wow, look at that. Some kind of rotation going on there. That's interesting. And there we are. That's a red frame. That's wonderful. So I'm going to do this and set it to the side. So this looks okay. I'm going to have to think about that. Now this is not my data per se. I don't know what's going on there, but I'll think about what's going on there. It's a fixed pattern that's getting rotated there because of the interpolation, because of the registration. So that looks okay for green. This is blue. Okay. Looks good. And then finally, we'll look at the famed luminance data. Look at that. So you can see rejection that's caused by the difference in the seeing, of course. We can also see rejection of the satellite trails, which looks good. Here's the low-end rejection, which looks fine. I'm not expecting to see very much. So there's the luminance, which looks fine. Fuzzy, but fine. One thing that might be of interest is to look in the FITS header, where we can actually see exactly how many frames ultimately were integrated. So what it shows here is that 36 frames were integrated. Now we fed it 37, so it's very likely that it's either the frame that didn't get the normalization property wasn't included, but I don't think that's what happens. So I think it wasn't included because of the threshold that I put for the weight, which could also be the reason. But good things were happening in the sense that it didn't integrate all of the frames. If they were bad, then that's fine. That would be an excellent result. I'd have to do a little more detail. If we put the files through subframe selector, we can actually see the weights that were given, and then we can do more analysis. I'm not going to do that here, but this then concludes a successful execution of a monochromatic, that is with grouped filtered colors, data, as well as a demonstration of the use of local normalization. I hope you enjoyed this information, and now you have the power to do it all on your own.